right, so today we're going to be looking at reviewing 8.1, and then we're going to jump into 8.4 and 8.3, actually doing some hypothesis tests themselves. For proportions and for means. Today you have due Math 7.3, and also project 4B can be turned in today, late for full credit. This is your last chance to do that. Thursday, project 7 is due. However, you can turn it in late for full credit up until April 13th. So you have really some time to work with on that one. And then after spring break, you'll have some other ones due. 8.1 and 8.4 will be due as well. Remember, you folks do not have class on Thursday because that's kind of the day, the flex day, right, that you guys had class. So this is your last class before spring break. Also, if you're interested in being a tutor, we need some tutors. We need several tutors. So anybody who's gotten like a 95% on both exams or higher, which is a number of you, consider being a tutor. They pay a little more than the minimum wage, like $15.50 an hour. It looks good on your resume. It's pretty flexible hours. They want you to work ideally at least 5 hours a week, but there's a pretty big range in there. And just make sure you get your applications in by the 9th, because if it's late, then they won't be able to process them. All right, and then spring break obviously is next week. So we do not have class. Don't come. I wonder if I should show you, if you're depending on what class you're in, you might have different due dates. So those are the ones for other classes. All right, so then chapter 8 was hypothesis test. Again, hypothesis test is a test to see if your sample is unusual or not unusual, assuming that H0 is true. Because H0 says that my mean or your mean is the exact same as everybody else's mean. It says that you are right there. If I get something in this range, in the kind of the usual range, then sure, it could be, my mean could be there. If I'm way out here, I'm thinking, well, I don't think my mean's out there, but it could be, it's possible. But as soon as I get over here, I'm saying, wait, I don't think my mean is there. I think it's something further this direction. So if you get something out here in what we consider unusual, what's our general guideline for unusual?
Under 5%.
5% or less. Then we'd say it's unusual, and it's more likely that our mean is not there. It's somewhere shifted. Good. The null hypothesis, H0, is a hypothesis. A hypothesis says that there is no difference between your population and the world's population. So in other words, your proportion equals everybody else's proportion, or your mean equals everybody else's mean. So the null hypothesis is always, always, always equals, no difference, right? If two things have no difference, then they're equal. So the null hypothesis is always, always, always,
Equal.
try it again.
Equal.
Null hypothesis is always, always, always
Equal.
equal. Good. The alternative hypothesis is that it differs somehow. It's going to be always less than, greater than, or not equal to. It'll have some other symbol. Okay, so for number 1, the claim is the mean of beauty winners is 105. So that means that the mean, mu, is equals 105. What's my H0? It's always, always, always what?
The same.
What's that?
The same.
Equals. It's not always the claim. It's always equals. So H0 is what?
Not equal to that? Not equal to
H0 is
105?
always, always, always what? Equals. H0 is always equals. So H0 is that mu equals 105. Remember, whatever number is in your claim, that's the same number that is in these guys. Does everyone hear me?
Yeah.
So that number stays the same. What changes is the symbol. H0 is always, always, always
Equal.
equals. So this has to be equals. Has to be. Is that the same as my claim? Is H0 my claim? What's my claim?
Equal.
It's the same.
Same, yeah.
Mu equals 105. Mu equals 105. Those are the same. Which means that H1 has to become the opposite of whatever my claim is.
So not,
What's the opposite of my claim?
not equaling to
Yeah,
105?
mu is not equal to 105. Is this one-tailed or two-tailed?
One-tailed?
Not equal to could be less than or greater than it's two-tailed. But how are you, how are you different? You could be less than or you could be greater than. Either one is not equal to. All right, so then this one, let's get a reader for this one. Raphael, go ahead and read.
For the following claim, express the claim in symbolic form, then state the null and alternative hypothesis. The researcher believes his oxygen levels will be higher than 65 milligrams Hg.
Great. Higher than 65. So he's claiming that his mean is going to be what?
Higher than
Bigger than
65.
65. Everybody good with that? What's my H naught? H naught's always equal. So in this case it would be U equals 65, exactly. Is that my claim?
No.
No. One has to be my claim. So if that is not my claim, H1 has to become whatever my claim is. So my H1 is going to become what?
Mu is greater than 65.
Mu is greater than 65. Great. Is this left-tailed? Is this one-tailed or two-tailed?
One-tailed?
One-tailed. It's right-tailed. Make sense? Just one side. Yeah.
Wait, why does H1 not become a complement in this scenario?
Because it used to be that we'd make this one less than or equal to and make that one greater than, but that just got to be messy for whatever reason. So now the current convention of the last 15 years, like literally 30 years ago when I was taking this, it would be, we would make this one less than or equal to, and that one be greater than. But for whatever reason, the last 15 years, they've just shortened it and made this just always equals. So if your claim is less than or equals to, then this would become greater than.
So in essence, H naught is kind of the complement.
It is kind of the complement.
Okay.
Yeah. But it's the one that includes equals. Oh, it's always the one that includes equals.
Okay.
Yeah. Like somewhere along the line, people said we just don't care about if it's less than. If our claim is greater than, then who cares if it's less than? It's just, yeah. So step 5, figuring out the test stat. Again, we don't worry about this one. This is at the bottom of your notes, I believe, of the last page. We talk about how to find the test statistic. So remember, the test statistic, the test stat is your sample's z-score. So how do you find it? You take your x bar, subtract the mean. How far is it from the mean? Divide by the standard deviation. For a mean, the standard deviation is S over square root of n. For a proportion, p hat, your sample, minus p naught, what you expect, divide by the standard deviation, square root of pq over n. However, you don't need to do those. You can just use t-test for the mean Mr. T, or one prop z-test for the proportions, easy peasy, p, z, proportion, one prop z-test. And both of those will give you your test stat and your p-value. So if we go back to this XORT method that we did before, last class, remember they said that they increase the likelihood of having a baby girl, which means that their claim is that they're, so here, do you all see the words mean or average here, and standard deviation?
No.
No, it's not there. It's not there. If you look for it, it's not there. That means this is most likely a proportion, and it is. It's a proportion that has 100 couples. Remember, proportions always give you the n and either p hat or x, the number of people who said yes. Which one did they give me? P hat or x?
P hat,
Where's p hat? Tell me where p hat is. Which one's p hat?
58 girls.
So this says 58 girls. 58 girls. So 58 girls is a percentage.
Oh no.
So it's the number of girls who said yes. Does that make sense? So that is an X. So thank you for trying. That's good because you're bringing this conversation along. That's awesome. So that is the number of people who said, yes, I'm a girl. Number of babies who said, yes, they're a girl. So what's the difference between a percentage, p hat, and the number of people who said yes? What's some other clues of, well, first of all, it's girls, it's not percent. What's another thing? What's the other big way of telling them it's an X and not a p hat? Emma? Anyone? You guys don't remember how to tell if it's, yeah?
Wait, can you ask the question again?
How do I know that this 58 is X and not p hat?
Because it's not a decimal.
It's not a decimal or a percent. Right? P hat's always going to have a percent symbol after it. Or it'll be a decimal between 0 and 1. Whereas X is always going to be a whole number. You can't have 25% of a person. Right? Everybody, is that making sense for folks? So, so this is X. And this is my N. Which means that my P hat will be what? What was that? Almost. My P naught is 50% because that's what I expect. I expect to get 50% girls. Is that everyone kind of following that? So my P naught will be 50%. That's good. My sample, P hat is my, remember P little hat over it? That's my sample. Like X bar, P hat. For my sample, what did I get in my sample? What percentage of girls did I get in my sample? 58%. 58 out of 100. So 58 over 100, which is 0.58 or 58%. Good? Is everybody on board?
Yeah.
Good, good. So first of all, my claim is going to be that my percentage of girls is the same as everybody else. And as Rodessa pointed out, or Maria pointed out, somebody pointed out, I expect to get 50% girls. My P should be 50%. But they claim they increase the likelihood of getting a girl. So they claim that their percentage is greater than 50%. And then I'm going to do stat test 1 prop z test of 0.5. Stat test 1 prop z test. And I'm going to say I have 0.5. I have 58 out of 100 girls. And I'm claiming that I'm greater than. So I'm going to go over to the greater than part. Hit enter there, and then I'll shift it over. So I'm clicking on the greater than. And calculate. That gives me my, that gives me my z-score of 1.6. So that's how we get this z-score here. Is everyone feeling okay with that? So you do stat test for proportion, 1 prop z test. For mean, just stat test t-test. Plug in the values you have, and it will give you your test stat. And your p-value, which we'll talk about later. So you folks have quiz number 3. Is this a mean or is this a proportion?
Proportion.
How do you get to proportion?
It says proportion.
It says proportion. It also has a percentage. Right, does everyone see the 25%? That's a big clue that it's a percentage. So did folks find their test stat yet? People need just another minute to find that? Okay, go ahead and find that. Yeah, I feel like people have gotten there. So I know it's a proportion. And I know that this is my p hat. And I know that this is my, oh wait, that's my claim. Ooh. So here's the thing. It gets a little bit tricky, right? I have this percentage and I have other stuff. So my suggestion is always find your claim first. So my claim is proportion, ooh, I know it's proportion, is equal to 25%. So my claim is that P is equal to 0.25 or 25%. So that means that that's not my P hat. Does that make sense to folks? Find your claim. So it says the claim is proportion is 25%. So that's my claim. P is equal to 0.25. It literally says that's the claim. So that means that I know that's the claim. It's not my P hat. It's my claim. So then I'm going to pop over to the sample. Include 540 P's with 120 of them having yellow pods. This is my N. 128, is that my P hat or is that my X?
That's the X.
How do I know?
Whole number.
It's a whole number. Yep. So let me write out what I got. I got my P naught, or my P, 0.25. I have my X, 128. I have my N, 540. H naught is always what?
Equals 2.25.
Equal. So here P is equal to 0.25. Whatever number is in your claim, that's the same number you use for your H naught or H1. Same number. That's how you know what number to use in your H0 and H1, whatever is in the claim. So it means in my H1, then it will be that P is, well, what's my claim? My claim is H naught, it's the same. So I'm going to write the word claim next to it. And then I'm going to write the word reject next to that. Does anybody remember why I write the word reject next to it? Well, first of all, someone understand why I wrote the word claim next to it?
Yeah.
Because that's my claim. And remember, if H naught's my claim, then if I reject H naught, they're in the same boat. Rejecting H naught's going to reject my claim. So I'll use the word reject in step 5. If H1 was my claim, then rejecting H naught would support my claim. I'd use the word support in step 5. But for now, since H naught's my claim, I'm going to use the word reject. Yeah?
Is H not always reject?
Yes. And H1 would always be support. So whenever H1's my claim, I'd be using the word support. Whenever H naught's my claim, I'd be using the word reject. Because that's what happens when I reject H naught. Rejecting H naught rejects my claim. If my claim's H naught, if my claim's H1, rejecting H naught supports my claim. Yeah?
How do you know when it's H0 or H1?
Look at the claim. The claim is P equals 0.25. So whenever my claim includes equals, then H naught is my claim. Okay, so then since H naught is my claim, H1 has to become the opposite of my claim. What's the opposite of my claim?
Equals not.
Not equal to, yep. Not equal to 0.25. And then my critical value, aha. My critical value, this is a proportion. Am I going to use the T table or the Z table?
Z table.
Z table, easy peasy.
Lemon squeeze.
Z table. And so I'm going to use degrees of freedom of infinity, right, for any of the Z's. And there is no, there's no confidence level or sorry, alpha listed here, right? Does anyone see that?
Yeah.
So if no alpha is listed, what's my default alpha? What's my general guideline for unusual?
Under 5%.
5% or less. Does anyone remember that?
Yeah.
So it means my alpha is 5%. So I'm going to bust out my T table. Let's see if I can find it. Thank you. And I'm going to say, okay, my alpha, okay, so here I'm looking at tests. Do you have a one-tailed test or a two-tailed test? Two-tailed. How do I know it's a two-tailed?
Equals.
Not equal to. Whenever my H1 is not equal to, it's two-tailed. So two-tailed, my alpha is 0.05, and it's a z table, so I'm going all the way down to the bottom, 1.96. Good, good. So my critical value is 1.96. Ooh, but that's not perfectly accurate. Why? It's two-tailed, so it would be positive negative 1.96. Everybody on board? Now, I could plug this all in and find my test statistic, but I'm going to be lazy and I'm going to use my calculator. So everyone bust out your calculator. We're going to do it together. Is this a mean or proportion?
Proportion.
Proportion. So we're going to go to stat. Is everybody with me on this one?
Yeah.
Test. And I want one prop z test. What's my P naught? My claim?
0.25.
0.25. My X is
28.
128. N is
540.
540. Great. And what's my claim? My claim is not equal to. Oh, so yeah. So my claim is equals, which means that whenever your claim is equals or not equal to, you're going to use the not equal sign, because that would be your H1. And then we're going to calculate. And it gives you my z-score. Negative 0.70 when you round. Oh, how did I find that? Now I gotta go back and figure out how I found it. Stat test, one prop C test. And I put in 0.25, 128,
540.
one prop Z test, 0.25, 128, 540, and not equal to. I got a z-score of negative 0.70. Great. Perfect. Done. If you're going to do that, you don't need to find the critical value. It'll find it for you. But I just wanted to give you a little bit of practice finding it, because you may have a couple of homework problems that will ask you to find the critical value. But for the exam, you will not need to know how to find the critical value. You just need to be able to use the calculator program to do it. All right. And sort of one of the last things we talked about last class was the critical region. Right? So in other words, here's my critical value. It's sort of my guideline for what's unusual or not. It's based upon alpha. So it says that alpha should be the area in the tail. If you're beyond that, then you're less than alpha. You're unusual. So if your z-score is beyond that, this is what we call the critical region, the rejection region, the guilty region. Right? If you're anywhere over here, this is the non-critical, non-rejection region. We're not going to reject H naught. We do not have enough evidence. So get used to thinking of it that way. Not enough evidence, not reject H naught. Those go together. Enough evidence, do reject H naught. We do have enough evidence. So it's kind of like a trial, right? If you're right here, gosh, you sure look guilty, but I don't have enough evidence. Make sense? You're presumed innocent until proven guilty. So here, I wanna convict H naught, but I can't. I don't have enough evidence. It looks like I can reject it, but I can't. That sort of makes, is everyone kind of following? So if you're over here, then maybe take a bigger sample size, and then maybe you would have enough evidence, because that would give you more evidence. All right. So again, this is how I look at them. Maria, go ahead and read.
The critical unusual regions and non-critical unusual regions are separated by a z value or t value called critical value CV.
Yep. So again, these are the usual values, these would be the unusual values. And then remember they come straight from the same as chapter 7. Look it up in the t-table. And don't forget the very bottom row of the t-table is your z-table. So this I showed you last class. If it's right-tailed, so you look at from the t-table. If it's right-tailed, you make it positive. If it's left-tailed, you make it negative. If it's two-tailed, you'd have one of each, positive and negative. Use degrees of freedom of n minus 1 if it's a mean. If it's a proportion, you do use degrees of freedom of infinity, because that would be your z-table. How to remember? Easy peasy. PZ, proportion z-table. Mean looking Mr. T. Right? If it's a mean, you're going to use a t-table. And here's the t-table itself. So here's the thing. It gets a little bit trickier now, because now we have to look at the other rows. If it is two-tailed, in other words, your plane, your H1 is not equal to, that's two-tailed. If it is one-tailed, that means your H1 is either less than or greater than, either one. That's one-tailed. And you use that one. You cannot use the same, you gotta keep those two columns, those two rows straight on which one to use. Because if you use the wrong one, then you're going to be grabbing an incorrect number. All right. So I am going to have you folks find some critical values. So this is in your quiz. Again, as a reminder, if it's below the mean, it's negative. If you want something less than, if you want something greater than, that'd be positive. So I'll give you folks one more minute to find your Z or T critical values.